Let's take a look at this problem. We got f of x is equal to 3 times x plus 4 squared minus 5, and x is less than or equal to negative 4. Well, they tell us the domain. X is less than or equal to negative 4. So that's going to be negative infinity to negative 4, written in interval notation. Now, but let's talk about our range. 3 really doesn't affect anything, but it does open up because it's positive. So since this is positive, I know my parabola is opening up. This is down 5. And when a number's inside with the x, it shifts left to right, opposite what you think. The plus 4 would make you think it goes right 4, so it's left 4. Okay, so we got a parabola opening up. It's moved left 4, down 5. 1, 2, 3, 4, 5. So it would look something like this. 3 again affects how much it opens up, whether it's wider or thinner. But that doesn't matter. I'm thinking about the range. Okay, it starts down here at negative 5. So the range is going from negative 5 and it's going up forever, so that's positive infinity. Now normally this would not be 1 to 1 because it has an even power, but they put a condition on it. By putting a condition on it, you're only looking at one part of the graph. So for example, the negative 4, we're looking where x is less than or equal to negative 4. We're looking at the left side of the graph, this right here. So that's the only part we're taking a look at. Okay, well, let's go through our steps. Step 1, replace f of x with y. Step 2, interchange x and y. So we got x is equal to 3 times y plus 4 squared minus 5. Step 3 is solve for y. So I take negative 5 over, becomes a positive 5. I'm going to divide both sides by 3. And those 3's cancel. And we got x plus 5 over 3 is equal to y plus 4 squared. Now whenever you have something squared equals something else, you drop your squared and you put a plus or minus square root on the other side. Well, to begin with, we can't have a fraction inside of a radical, so we'll split this up, put a square root around the top and square root around the bottom. We also can't have a square root in the denominator, so we're going to multiply the top and bottom by the square root of 3, and you'll see why here in a second. Now when I multiply two radicals together, I multiply what's underneath them. So I got 3 times x plus 5 inside the square root. And down below, a square root of 3 times square root of 3 gives you a 3. Because it gives you a square root of 9, which is 3. Equals y plus 4. Take the negative, or take the 4 over, it becomes a negative 4. Plus or minus, and then up on top I can multiply that through, and I get 3x plus 15 over 3 is equal to y. Now, for our, let me reverse this. I'm trying to think if it makes any sense to get a common denominator. It's hard to say what the book would do. Anyway, I'll show you the form in a second. But our inverse would be negative 4 plus or minus square root of 3x plus 15 over 3. But we can't have the plus or minus. So if I think about these right here, for our domain and our range, they swap for the inverses. So if our domain is negative infinity to negative 4, then our range will be negative infinity to negative 4 down here. Now for our domain, if the range is negative 5 to positive infinity, our domain will be negative 5 to positive infinity. So the domain and range just swap on those. Okay, how does that help us? Well, remember back up to here we said y is equal to all of this. And y is our range. And we're saying y is less than or equal to negative 4. Well, if I add a value, then it's not, if I have negative 4 plus a value, it's not going to be less than or equal to negative 4 anymore, which means I want to keep the negative version. So I have negative 4 minus square root of 3x plus 5 over 3. Now they'll also put the domain on here just because it's a square root. And domain is x is greater than or equal to negative 5. Now if they get a common denominator, they would rewrite this as negative 12 over 3 minus square root of 3x plus 5 over 3, which then gives you negative 12 minus square root of 3x plus 5 all over 3 with the same condition. It's hard to say. Some books consider simplified form as a single fraction, so this first answer would not be in the right form.